Ulysses, launched on October 6, 1990, sent to study the Sun at different latitudes. With a mission to get close-up pictures of the poles of our star, Ulysses needs to be launched into a so-called near-polar orbit, an orbit circling around the two poles of a body. Now the problem is, planet Earth is, just like the other 7 planets in our solar system, in a near-equatorial orbit, meaning that it follows roughly the equator of the Sun. So the question arises, how do you get a probe hovering around the Sun's poles when its propulsion system does not even come close to having the necessary power? The answer? A gravitational slingshot, also known as a gravity assist or a swing by. Let's imagine that a perfect bouncy ball is thrown against a solid wall. If the velocity of the ball before collision is defined as v0 and a perfect elastic collision occurs, v1, the speed after impact, will be equal to v0, just opposite in direction. This analogy can be used for a probe making a hyperbolic path around a body. With respect to the planet, the probe will keep its velocity, just with a different direction. That is how the course of a probe can be altered by using a planet. But a gravity assist can do more. It can also increase or decrease velocity. We will see this when we take the motion of the planet into account. Going back to the analogy of the bouncy ball, if instead the ball is aimed at the front of a moving truck, v1 will be a function of both v0 and v-truck. Before impact, the difference in speed between ball and truck equals the speed of the ball minus the speed of the truck. So, for example, 50 km per hour. After collision, this relative speed will be the same, but in opposite direction, as we have concluded before. That means v1 will be equal to 50 km per hour relative to the truck, or 80 km per hour relative to the ground, an absolute increase of 60 km per hour, since the ball started at 20 km per hour. Well, a gravitational slingshot does exactly the same, except for the fact that it uses an hyperbolic orbit instead of an head-on collision. What I put on screen is of course an example in the 2-dimensional plane, but a gravity assist can also be used in 3-dimensional space, so an orbital inclination can be obtained, and that is exactly what NASA and the European Space Agency managed to do. Get Ulysses swung around Jupiter into an inclined elliptical orbit of 79 degrees that circles through the solar system every 6.2 years and enables it to research the north and south pole of the Sun. And that by just stealing a fraction of the momentum of the gas giant that we call Jupiter. After 18 years of service, in 2009, Ulysses ran out of fuel, and now his watch is ended.